Hey there, fourth graders, how we doing today? Your assignment was Wavelength, page number 4. Here we go, let's look at this text. For centuries, scientists observed waves and studied their properties. However, observations can be misleading. If you watch an ocean wave, it looks as though the ocean is moving forward. That is not the case. It says observations can be misleading. You know what that means? It means that what you see and what you think you see is not really what is actually happening. It's kind of tricky. Sometimes we get fooled. Well, let's keep reading, see if we can understand that. Second paragraph says, when a wave passes through a medium, like solid liquids or gases, a medium such as water, it does not move that medium forward. Instead, the wave energy moves the medium up and down. The highest part of a wave is called the crest, while the lowest part of the wave is called the trough. There's some basic wave vocab. Great words. Put them in your brains. Third paragraph. Scientists who measure waves use the term wavelength to describe the distance between two crests or two high points of a wave. Sometimes wavelength is short, and other times the distance between two crests is very far. It all depends on the wave. There's all different kinds of waves, and they have different wave lengths. Let's finish up here. In sound waves, a short wavelength creates a high note, while a long wavelength creates a low note. In light waves, different wavelengths cause our eyes to see different colors of light. How cool is that? Red has the longest wavelength, and violet has the shortest. Alrighty, let's look at our questions. Number 1 says, according to the text, how does a wave affect the medium that it passes through? Well, we've got to go back up to the text, paragraph 2. I underlined it here. How does the wave affect the medium? Paragraph 2 says, instead, the wave energy moves the medium up and down. Not forward and backward, like a wave at the ocean, but wave energy causes a medium, causes that water to move up and down, up and down. That's what the wave energy does. Number 2, we have to label the crest, the trough, and the wavelength. Let's take a look here. Notice on the left side I've labeled the top part there the crest. Down in the middle, the bottom part, I've labeled the trough. And then the distance from one crest to the next is called the wavelength. Alrighty, moving on. 3a. How do changes in wavelength affect the light that we see? Different wavelengths help us to see different colors. There you go. Different wavelengths, different colors. Pretty amazing stuff. 3b. How do changes in wavelength affect the sound that we hear? Well, sounds that have a short wavelength make very high notes. And sounds that have longer wavelengths, they make lower notes. Short wavelengths, high notes. Longer wavelengths, lower notes. And now down at the bottom, number 4. We have to draw a wavelength that represents red and a wavelength that represents violet. Well, if you look at the rest of the diagram, you can see there's a definite pattern. As you go from red down to violet, the wavelength gets shorter and shorter and shorter. So by the time you get down here and you draw a violet color wavelength, it should be shorter than all the others, even shorter than blue. Short, short, short. What do you think that means about the first one up here, red? How long do you think a red wavelength should be? If you said it should be longer than orange, you got that one right. Red wavelength is longer. In fact, it's the longest one on the diagram. And violet should be the shortest.